Now, you can use the very same procedure on arguments too. For example, the argument for all x, tet x implies large X, not large A, so not tet A. This argument looks valid, but is the conclusion a first-order consequence of the premise? Well, let's do our replacement. Let's replace tet with the predicate, the meaningless predicate Borogrove, large with the meaningless predicate Mimsy, and we get the argument for all x, if Borogrove x, then Mimsy x, not Mimsy b, so not Borogrove b. Well, it's pretty easy to see that if all Borogroves are Mimsy and b is not Mimsy, then it can't be a Borogrove, even without knowing the meaning of these predicate symbols. So we can judge that the conclusion of this argument, the original argument, is a first-order consequence of the premises.
Let's turn to the question of counterexamples now. Recall that to show that a sentence was not a tautological consequence of some premises, all we had to do was find an assignment of truth values to the atomic formulae which make the premises true but the conclusion false. That situation is a counterexample to the claim that the conclusion is true whenever the premises are on the basis of the propositional connectives.
I remember that.
Well, the basic idea is the same when you're looking for a counterexample to a first-order consequence claim. We still have to describe a situation in which the premises are true and the conclusion is false. But what counts as a situation is a bit different. Here's an example argument in the blocks world. The premises are not there exists x larger x A, which tells us that A is a largest object in the world. The second premise is not there exists x larger bx, or that B is a smallest object in the world. The third premise tells us that C is larger than D, and the conclusion is that A is larger than B. Is the conclusion a first-order consequence of the premises?
The answer is no. Although this may seem like a valid argument in the blocks world language if you think through it, because larger CD tells us really that there are at least two sizes in this world, and so it does indeed seem like A must be larger than B. The answer is no. This reasoning requires that we pay attention to the meaning of the predicate larger in order to make it go through. So first, let's try to make sure that we don't use the meaning of this predicate by replacing it with the meaningless predicate. Say, we'll just use R this time. So replacing larger with the meaningless predicate R gives us this argument here. Now let's describe an interpretation for R in a situation that makes the conclusion false while making the premises true. Imagine, for example, that we have a situation that looks something like this. Imagine we have four objects, A, B, C, and D, and the relation R holds between C and D. Now, just imagine that R means likes. And so we have these four objects, and C likes D, but there's no other liking going around. Then the premises are true under this interpretation of R. No one likes A, and B likes no one. C likes D, and yet A does not like B, right?
So to be a first-order consequence, the conclusion must follow from the premises, whatever the meaning of the predicates in the argument. And here, we've exhibited an interpretation of the predicate R as this liking relationship, together with a situation that falsifies the conclusion while making the premises true. So this shows that the conclusion is not a first-order consequence of the premises.
So we can describe this procedure like this. First, replace all the predicate symbols, except identity, with meaningless predicate symbols. Make the replacement consistently. Every occurrence of a predicate symbol is replaced by the same new symbol. Second, to see if S is a first-order consequence of P1 through Pn, try to find an interpretation and a situation in which S is false and P1 through Pn are true. If you can, S is not a first-order consequence of P1 through Pn. If there is no such counterexample, then it is.
So you'll notice that this method for determining first-order consequence is not as routine or straightforward as the test for tautological consequence. In that case, we had a set of rules to follow, and while possibly time-consuming, we'd always get a definite answer. The problem with this procedure we just outlined is that if you've failed to find a counterexample after, say, 18 hours of trying, and I recommend at least 18 hours of trying, This doesn't mean that the sentence is not a consequence of its premises. You can only reach that conclusion if no counterexample exists. You may have failed to find a counterexample because none exists, but maybe you failed to find a counterexample because you haven't tried everything yet. Maybe there is a counterexample that you just haven't found.
And maybe you're not creative enough. But it turns out this is very bad news here, because there's no mechanical procedure for finding out whether one sentence is a first-order consequence of some others. If we knew it, we would tell you. But the method that we've given is the best that we can do.
And it's not just that we don't know it. There's no point in asking anyone else either what the procedure is, because they don't know one either.
And there's no point in waiting for someone to do some more research and figure out a procedure for doing this. That's not going to happen.
The situation is as bad can be. It's not just that no one knows the procedure. It turns out there's a proof that no such procedure can exist.